Good day, everyone. I want to do the experiment today. It's perhaps not really a scientific experiment. It's a math experiment, and I want to illustrate concepts of recurrence, recursion relations, and to do that, I'm going to use the Tower of Hanoi puzzle. The Tower of Hanoi puzzle can be found in many computer science texts, and it's a great illustration of certain principles of mathematics and how we can solve certain problems by successively building up the solution to the problem from a small problem up to a large problem. Now let me show you how we do this. Here I show the Tower of Hanoi. Now the Tower of Hanoi puzzle was originally proposed by a mathematician called Edouard Lucas, French mathematician, about 1883. And the way the puzzle works is something like this. And then here we have a stack of disks, smaller disk on top of larger disks. And what we want to do is somehow move this whole stack of disks from one post to another, either this one or that one. And we want to do it by moving the disk one at a time. But the rule is we can never place a large disk on top of a small disk. So, for example, we can't place this disk on top of that one. That's a violation of the rule. So in order to see how we solve this problem, let me first consider the simple problem with only two disks, as shown right here. So let's say we want to move these two disks over to this post. We move the disk one at a time, never moving a large one on top of a small one. So this one's pretty easy. We'll first move the small disk over here, then move the large disk over here, and then move this one back. Pretty easy. Now that took three steps. We had that was 3 steps. Let me just do it again so you can see. We have 1, 2, 3 steps. Now suppose we had a disk, a third disk, so we have a tower of 3 disks, and suppose we want to move this whole tower from this post to this post. Well, if you think about it, in order to do that, first we have to move 2 disks over here, then we have to move this one over here, and then we have to move these 2 disks back. So without even solving the problem, I can tell you how many steps it would take, because to move 2 disks over here, following the rules, takes 3 steps. Moving this one over here takes another step, so that's 4, and then moving these 2 disks over to this post will take 3 more steps. So that's 7 steps it would take. Let's see how we would do that. Okay, first to move the 2 over to here. 1, 2, 3, 4. Now we want to move these 2 over here. 5, 6, 7. So that's how we move 3 disks, knowing how we move 2 disks. Now suppose we had 4 stacked up, as shown here. And if we wanted to move these 4 over to that post right there, first we'd have to move these 3 over to this one, which we just did. Then we have to move this one over here, and then we would have to move these 3 again back here. So how many steps would that take to do that? Well, in order to move these 3 here, that takes 7 steps. We just figured that out. This is 8. And then 7 more steps to move these 3 over here means a total of 15 steps. So let's see how we would put that all together, see if that's the way it works. Okay, here I gotta go. First move 2. Move the small one here, this one here. Okay, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now let's pause here for a minute and let's investigate what we have learned to this point. We have learned to move 2 disks takes 3 steps. Okay, now 3 is equal to 4 minus 1. 4 minus 1. To move 3 disks takes 7 steps. 7 is equal to 8 minus 1. To move 4 disks takes 15 steps. 15 is equal to 16 minus 1. Now, what is the significance of this? Well, 3 steps, which is 4 minus 1, is 2 times 2 minus 1. 7 steps, which is 8 minus 1, is 2 times 2 times 2 minus 1. 8 minus 1. 15, which is what it takes to move 4 steps, is 2 multiplied by itself 4 times. That's 16 minus 1, which is 2 times 2 times 2 times 2 minus 1. So we can figure out the number of steps it would take at a minimum to move all the disks from one post to another by using powers of 2. So if to move 4 takes 2 to the 4th, that's 2 multiplied by itself 4 times minus 1. If we wanted to move 5 disks from one post to another, that would be 2 to the 5th, or 2 multiplied by itself 5 times minus 1. Okay, 2 to the 5th minus 1 would be, 2 to the 5th is 32, it would be 31 steps. Okay, to move these 5 over from one post to another. So how would I do that? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. And how does that work again? To move this whole stack, we can say to move that whole stack over to that one last post, first we have to move all of these over to here. That's 15 steps. 16, and then we have to move all of these over to here, which is another 15, so that's 16 plus 15, or 31 steps. So we can solve the Tower of Hanoi puzzle, or we can figure out how many steps it would take as a minimum to solve the puzzle by counting the number of disks. Okay, and then we take 2 raised to that power, so here I have 7 disks, so to move this whole stack from one post to another would be 2 to the 7th minus 1. That's how many steps it would take. As you see, the number of steps actually grows quite large. In fact, there's a legend that goes with the Tower of Hanoi puzzle. The legend goes something like this, that there's a Buddhist shrine with Buddhist monks, and these monks have a stack of 64 golden discs. And they move 1 disk a second to solve the Tower of Hanoi puzzle. And when they're finished moving the disks, that's when the end of the world will come. Now, how long would it take to have a 64 stack puzzle at 1 a second? It would be 2 to the 64 minus 1. That's a big number. You can go to your calculator and figure it out. But it adds up to something like about 585 billion years is what it would take to solve that 64 stack puzzle. So we see how we can solve the puzzle. We see how solving the puzzle for 7 depends on knowing how to solve the puzzle for 6. Solving the puzzle for 6 depends on knowing how to solve the puzzle for 5, and so on. So let me just finish up. I'll go through. I'll do the whole 7 stack for you here, and just to show you that it can be done. And now I'm going to solve this puzzle with a stack of 7 disks. You can count the steps as I do them. Maybe you can begin to see a pattern in how I'm doing this. Maybe not. Of course, I haven't memorized how to solve the puzzle. What I remember is the pattern of how to solve the puzzle. Voila. So that's the lesson on the Tower of Hanoi puzzle. See you next time.